Welcome back, everyone. There's another little video clip to introduce our next section in the review here we're doing, solving linear inequalities. We're going to be looking at in this section. So we'll be looking at solving them similar to solving the equations, but there are a few extra little nuances that are different. So let's first look at a little cartoon as we get started. So here's another Far Side cartoon. A dog is outside the window. I guess somehow, saying, "Put the cat out, put the cat out." So hopefully he would make the owner put the cat out and then he'd go get the cat. Alright, so let's take a look at our inequalities here. Solving linear inequalities. Now there's a couple things we need to look at as far as this. We can notice that as we look at example 1 here, you're noticing this kind of similarity to the equations. You're undoing the 1 by subtracting, you see plus, and so you're going to subtract. You're going to subtract that on both sides. You notice, okay, I do the operation over here. That's all the same. So when you do addition property of inequality, it is all the same. Everything is the same. When you do subtraction property of inequality, it is all the same. You're going to do whatever you do to one side, do the same to the other side, and it's all fine. The change comes in when you're doing the multiplication and the division properties. So that's why it shows you two cases. Case 1, when you multiply or divide each side of an inequality by the same positive number, and that you may want to highlight right there, it's italicized, positive number, then the inequality does remain the same. It's all the same, everything's fine. But on case 2, when you multiply or divide each side of an inequality by the same negative number, then the direction of the inequality symbol must be reversed for the inequality to remain true. So that is the one thing you need to remember when you're doing inequalities, is that you have to flip the direction or change the direction of the inequality sign, that greater than or less than sign, when you're multiplying or dividing by a negative number. So this, you definitely want to make sure you highlight that part right there. This needs to be highlighted. You need to understand that part right there. When you multiply or divide by a negative number, that means the direction is going to be reversed. Direction will be reversed of the inequality. So you can just say, flip the inequality sign or change the direction of the inequality sign. Make a note of that to yourself. And you can see here's one that does that, where we're going to divide both sides by -3. That's what we would do on any equation anyways. Divide by -3, but since our sign is negative, it's a negative sign here. That's a -3. You're dividing by negative. Notice the sign of the inequality sign. It would start off as a less than, and now it changes to greater than. It starts off pointing to the left, and now it ends up pointing to the right. So it flipped. It changed the direction of the sign. Now on inequalities, the thing about an inequality, it's different about an equation. It's not equal to a specific number. It's actually equal to a range of numbers. That's why it's an inequality. They're not equal. So if we look at the solution of this, we can actually graph out the solution to see more of a picture of the solution. If this was an equal sign, our graph would just be a dot right there at 2. But since it's an inequality, it's really a range of solutions here. This would mean x is greater than 2, so x is all the numbers that's greater than 2. And so the first thing we need to do is know what kind of hole are we going to have, or circle we're going to have at that 2. And it's going to be open because x equals 2 is not a solution. Notice this one, though, is closed. You're going to use a closed circle because in this case, x equals -3 is a solution because notice it has a little line underneath the inequality sign. It says greater than or equal to. So it is equal to -3 on this one, so we put a closed hole. It's not equal to 2. There's no equal to sign on this one. It's just greater than 2. So we don't put a hole on a closed hole here. We just put an open circle to show it starts at 2, but the answer is everything that's greater than 2. So we're going to shade from this point of that circle all the way to the right, which is greater than 2. And you might think, well, that's easy. Just always shade in the way the inequality sign is pointed. That's fine as long as your variable comes first, as long as it says x is greater than or x is less than. But if for some reason this inequality was flipped and so the number, then the inequality sign, and the x was last, then you would actually be doing it the opposite way and you could end up getting it wrong. So just make sure you kind of read it. X is greater than 2. Remember, it's open. The alligator opens to the x, so it's going to be bigger. X is bigger than 2, greater than 2. Or in this case, x is greater than -3, also shades that same direction to the right. Everything that's greater than -3 as well as including -3. All right, here's another couple examples where we're going to do more than just one simple step. It's got a couple steps here. So this one we subtracted 2 and then we eventually divided by +9. So notice we don't switch the inequality sign here at all. As we're subtracting by 2, that doesn't do anything to switch the inequality sign or change its direction. And when we get down to this point, we're going to divide by a positive number, +9, so that also does not change the direction. But notice how this is set up. The y is over here. So when they wrote the solution, they flipped it around. They flipped the whole thing around, including the inequality sign. So -3 is greater than or equal to y. You can flip the whole thing around and say, well, y is less than or equal to -3, or it's kind of like you're reading it backwards, starting with the y. Y is less than, because the arrow is pointing to the y. The arrow still needs to point to the y even when you flip the whole thing around. And as you graph this, because it's also equal to, we're going to put a closed hole, and it is less than, y is everything less than -3, so you're going to shade to the left. This one, you can see we're got a fraction on this one. First you want to get rid of the 6 though, subtract the 6, that way you just have the fraction then on the one side, and you can multiply by -2. So in this case you are multiplying by a negative. To solve this, so that means you are going to switch the direction. You can see it starts off greater and eventually now it switches to less on the inequality sign. And so z is less than -8. Since it doesn't have that little equal to, we're just going to put an open hole on this one and then shade the direction that it shows. And we can shade it this way since z comes first, but z is less than the -8. So we'd shade that way. If you had it here and you ended up shading to the right because you see the arrows pointed this way, you would have shaded it wrong, as you can see, because this really means y is less, and less would be going to the left. Less is left. You might want to remember that. So we'll figure out which one is it. Is it less than? Y is less than. -3 is greater because the mouth is opening. It's going to, the alligator is going to always, choose the one that's greater. Okay, so let's do a few of these practice ones together, and then I'll let you do these other 3 on your own. So starting with number 1, and we're going to solve and we're going to graph the solution. So I'm going to solve it up here, and I probably will graph it down below. So to start off, just solve it like a regular equation. We know we would have to be subtracting 2 to solve this. We're going to subtract 2 from both sides of this inequality. Cancels the 2's out. So now we can see our answer for this one is going to be x is greater than, it doesn't change, subtracting 2 does not change the direction, only multiplying or dividing by negative does. So do the operation here, that's going to give us a +5 over here. So there is our solution. That would be our solution to the inequality. When it says solve it, now we want to graph this inequality. So we're going to go ahead and put a graph down below here. So again, this is number 1's graph. And I'm going to draw a number line. I'm actually going to make this a little bit, it's hard to draw straight lines with this. So I'm just going to go ahead and give me a perfect straight line here. Actually, I'll put some arrows on it. I think about it. Let's see. Okay, so I just put all 3 number lines just down here so we can use them. So we're going to now graph the x is greater than 5, so we want to figure, okay, where's 5 going to be? So we want to always put 0 here somewhere. So I'm going to put 0 over here on the left side. That way I can do 1, 2, 3, 4, 5, and here would be 5 right here. We need to make sure we label 5. Since there is no equal to sign on this one, we're going to be putting in a open hole right here, and it is x is greater. And so we definitely going to be shading to this side here. So we're going to shade this way to the right, put an arrow on my shading, and there's our graph. All right, let's go on to this number 4 problem. We see it's a fraction, so whenever we see fraction, let's get rid of that fraction, right? So let's multiply both sides here by 5, the denominator. Always multiply by what's on the bottom, the denominator. And so that's going to cancel out the 5 down here. Leaves me now with just the 2s. Because this 5 cancels with this 5. And now I just have 2s is less than or equal to 6 times 5, which is 30. And now I'm going to divide by 2. And since 2 is positive, that does not change the direction. So we're just going to be able to cancel out those 2's. Say s is now less than or equal to 15. So there's my solution right here. S is less than or equal to 15. So for number 4, I'm going to go ahead and put 15 on this graph somehow. So let's put 0 right here. And I'm going to go by 5s, in fact. So I'm going to go, 5. And then I'll say this is 10, and this will be 15. Make that a little faster. And it is equal to, it has a little line underneath one, so we want to include 15 as a part of our solution, so we're going to use a closed circle or hole, and it says that it's less than. So S is everything less than 15. Less than is going to go off to the left, like 10 is less than, 5 is less than, all these are less than. Put an arrow on your shading, so that way it's going that direction to the left. All right, number 5, as we solve this one, we're going to start by subtracting 1 from both sides. And so it's going to give us this negative 2q. It's greater than or equal to 14. And then we're going to divide by negative 2. And since 2 is negative right there, we will have to change the direction of this inequality sign. So q, instead of greater than, it's going to go the other direction, less than or equal to, and 14 divided by negative 2 is negative 7. So there is our solution for this one. Let's go on to the graph. Let's go and put negative 7 here. I'm going to put 0, kind of more maybe to the right this time. Put 0 over here. And there's negative 1, negative 2, 3, 4, 5, 6. So here's negative 7 right there. And should we put an open or closed? Let's look at the inequality sign. It does say equal to, so that means it's going to be a closed circle, because it's also going to include this number, negative 7, in the solution. So closed when it's equal to. And when it's not equal to, it's open. So that was number 1 was not equal to, and so that was open, but 4 was closed because it was equal to. So this one is less. Q is less than the negative 7. So less than negative 7 would be going to the left. This is less, left is less, or less is left. So go to the left when you're going less than. Q is less than, right? Because the negative 7's greater, that mouth is opening to gobble up the negative 7. So that means that Q is less than negative 7. All right, let's go on to the next section now, which is going to be more of the compound. So go ahead and pause the video. Actually, that's what you want to do next, sorry. Pause the video, and you're going to go back here and do 2, 3, and 6. So complete those, and then move on to the next section in the video. All right, so a quick little break for a joke of the day. What do you call a belt with a watch on it? What do you call a belt with a watch on it? A waste of time. A waste of time. A little play on words. Because the belt goes around your waist, of course. All right, moving on to our next part here is compound inequalities, solving compound inequalities. So what is a compound inequality? It's formed by joining two inequalities with the word and or the word or. And if it's the word and, sometimes they don't even use the word and, they just kind of all jumble it together. They put it one long, big inequality. So the first example here is showing us just how we can write a compound inequality as an inequality. So here it says letter a number x is greater than negative 8 and less than or equal to 4. So you want to figure out, okay, where is the main, conjunction word or, compound word? In this case, it's and, because you have a number x is greater than negative 8. So there's one inequality. X is greater than negative 8. X is also less than or equal to. So this or right here is a part of the or equal to part, which is a part of the inequality sign. This is the and that separates the two inequalities. So you want to see, here's our first inequality. X is greater than or equal to negative 8. And X is also less than or equal to negative 4. So you can write that this way with the word and, or we could also put it in this way, where you can see the and's not there anymore. They made it one just kind of compound inequality. So they basically kept this one the same. X is less than. They're going to use the less than one the same, but the greater than one will end up kind of getting flipped around. So it'll be like negative 8 first, then less than X. And then they'll just kind of merge the X's together. So you kind of merge the X's together. Let me show you what that would kind of look like. Okay, so I flipped the first one around like I said. See, X is greater than negative 8. I flipped it around to be now a negative 8 is less than X. See, the arrow is still pointing to the negative 8, so it's still the same inequality. And what we're going to do is I'm going to kind of get rid of the and word. So I'm going to kind of just get rid of that, move that out of the way, and then kind of merge these two together. So let me kind of show you how that might look. If I was to just move this over, merge them together, it would kind of look like that. And so there you have what it says right here. So that's what they just kind of did. So they flipped the greater than one around so that it's all going to be less than. So when you are writing it out like this, a compound inequality with the word and like this, it's all going to be less than symbols in here for it to work right. And then you're just going to merge your x's together. Merge your two inequalities together on x. And so what it does here, we have two inequalities, so we're going to have two holes. We have a hole at negative 8 and a hole at 4. You can see on the negative 8, it's going to be just open because it doesn't include the negative 8, but it does include the 4, so we close that one up because of the equal sign here for the 4. And the shading on this one is going to be in between these two holes, so the answer for this is that x is everything that's in between negative 8 and 4, and it also includes 4. So as you can see, it's going to be x is greater than negative 8, which goes this direction. X is less than negative 4 going that direction, or x is less than positive 4 going to the left. Now the next one, B, is got the word or in this one. So here's your first inequality. Y is at most 0, or y is at least 2. So remember, you think of y is this or this. So this one is an or instead of an and. So your first inequality, y is at most 0. The at most is going to be a less than or equal to. So that means it's basically saying the most it could be. So it could be less, but the most it could be is 0. So negative 1 would, be a solution to this, because the most it can be is 0. It can't be any more than 0. It can't be greater than 0. But it could be 0, or it could be less than 0. That's why it's y is less than or equal to 0. This one, at least, y is greater than or equal to 2. The least it could be is 2. It cannot be less than 2. That's what it's basically saying. So this one is saying cannot be greater. But the at most, maybe we'll write this down here on your notes when we're seeing this. The at most right here, when you see that word, at most, that means it can't be greater. So can't be greater than whatever number it says, than 0. It can't be greater than 0. The at least right here, that's just the opposite. It can't be less than whatever the number says. It can't be less than 2. So that's why it can be 2, it just can't be less than 2. So y is greater than or equal to 2. So that's one thing you want to see about those words and how to write the inequality. And then down below here you can see we got two closed holes because they're both going to be equal to signs, and they're shaded the opposite direction. When it's an or, they're going to go in opposite directions. This way or that way. And as you just can see, you can read the inequality signs. That's what's happening. Let's move on to our next section here. Here's another one where it says now to solve it. So we're going to go into solving these. Maybe I'll come back to this in a minute. Let's go ahead and try a couple of these ones here. Let's just try this one. Number 2. Actually, no, I'll come back. Let's do this. Let's look at this one, and then we'll go on to that next section and try the problems. So this one, we're going to actually solve it. This would be one of those that would be an and, because it's all one thing. It's merged in the middle. And so really you want to think of it as an and. You want to put it back into two inequalities. You want to take this part here, this first part, and make an inequality out of that. And then the second part, which is right over here, this second part, make an inequality out of that. X minus 2 with less than 3 is an inequality you're going to solve. Negative 4 greater than x minus 2, you're going to put that over here. You're going to solve that one. So you solve each one separately to get your two separate answers. And then you're going to just merge them back together right here on x. Merge them back together so you can see your solution. So that would be your solution. They're both both open holes because there's no equal to's on these ones. So open on both. And since x is in between, the shading should be in between. You can just double check that that's going to be correct. All right, let's go ahead and try now some problems. Let's do number 2. I'll have you try number 1. Let's just do number 2 together. So a number a is fewer than negative 6. So right there, there's your one inequality. A is fewer than negative 6. Or there's your inequality word, your conjunction word. Or a is no less than negative 3. So let's write out two inequalities. We're going to use the or word here, and we got to use the letter A. It is fewer. So this, if it's fewer than negative 6, then it's not going to equal negative 6. It's just going to be A is fewer. Fewer would be less. A is fewer than negative 6. And then you want to use the or word in there, or, and then you can say A again is no less. So it's no less than. So that means it's greater. If it's no less, the opposite would be it's greater than. So A is greater than negative 3. So it says write the sentence as an inequality, graph the inequality. So let's go ahead and graph this inequality now. Let me write my number line down again. Okay, so here's our number line. We're going to put negative 6 and negative 3 on this graph. So let's put 0 maybe way over here on the right. And we got negative 1, negative 2, here's negative 3. And then we got negative 4, negative 5, negative 6. And so they're both going to be open on this graph. So let's put an open hole at both of them. So both open. And since it's an or, they should be shading opposite directions. A is less than negative 6 would shade this direction. So you can put shading here, put your arrow on the shading, go in that direction. And A is also greater than negative 3, which would go off to the right. So they are shading in opposite directions when it's the or word. So there it is on that one. If you want to stop the video and then try number 1 and then go on to the next part down below here where we're solving them. Okay, so let's go ahead and solve now for number 4 and number 6. Now number 4 is one with an and. It's a compound one here. So what we can do is, now it showed you a way to do that. You know, we could do it this way where you can write the word and like we saw here. Breaking it up into two inequalities. That may be easier for you than putting it back. I'm going to show you another way you can do that though. Without having to break it up, you can just kind of do it as you're doing it here. So you see, here's your k, the variable that you're trying to solve for. 2k minus 5. Well, the minus 5 needs to be taken away from this. So we're going to know we're going to have to be adding 5. So I'm going to add 5, in fact, to the left and to the right of our inequality symbols. So I'm going to add 5 to our 3 here, and I'm also going to add 5 to the 7. So that would cancel our 5s here. Leaves me with 2k now still in the middle. Let me put it on, well, I'll put it down here. 2k is still in the middle. In front of the 2k, we're going to see a positive 2. And then behind this 2k, we're going to see a positive 12. So now the next thing to do is to divide by 2. So we want to divide now everything here by 2. We'll divide this by 2 there. We cancel out the 2's. We're going to divide this left side by 2. We're going to divide the right side by 2. So our answer here is now going to start off with 1. 2 over 2 is 1. And then we have our less than symbol. We have the k now in the middle. And then the less than symbol again. And then 12 divided by 2 is 6. So here's our solution. And then we do want to graph the solution. So let's go ahead and do that here. Okay, so now we have our number line. We're going to put 1 and 6. So 0 for this one, I'm going to put off to the left this time. So we can put 0 over here. Always so you want to see 0, and then you got 1 right next to it. There's 1. Then 2, 3, 4, 5, and then here it would be 6. And so with this one, we have open holes. There's no equal to. So we're going to put our open holes at 1 and at 6. And since x, or I should say k in this case, k is in between, our variable is in between, we should be shading in between. We can always just double check. K is greater than 1. That's what it's saying from this direction. So greater than 1 definitely goes that way. K is less than 6, which is going to go this way. So you can see the shading does meet in the middle. Shading is in between. So remember, when it's like this, the shading should always be in between. All right, number 6 down below here. So there's 2. We have our or word on this one. So 2 separate inequalities. So first let's solve this one. We're going to subtract 1 from both sides. And so it's going to give us 2p. And we're going to see our inequality signs less than. Our operation here would mean to make a bigger negative out of that. They're both negative, so it makes negative 8. So you add and keep the sign negative. And then we divide by 2. Now since 2 is positive, we don't change the direction of the inequality sign. So that would still be, it would still apply here in this compound ones. If we are multiplying or dividing by negative, we will still flip the sign. So that's going to cancel our 2's out, so p is going to be less than negative 4. So there's one answer. And I'll put maybe the or word right here now. And over here, we're going to first subtract 3 to solve for this one. So minus 3. Cancels our 3's out. Negative 2p is less than or equal to negative 4. You have a negative 1 and a negative 3. That would add up to give you negative 4. Now here's where we see dividing by negative 2. That's our next step. And since we are dividing by the negative, we will need to change the direction of this sign. So our negative 2's would cancel. So p, and then we got to change the direction of this, is greater than or equal to. And then over here, negative divided by negative is positive. 4 divided by 2 is 2. So p is greater than or equal to 2. So this, now this whole thing here would be our solution to the inequality. So p is less than negative 4, or p is greater than 2 is our solution. Let's go ahead and graph it. I got the number line down here already. We're going to need to put negative 4 and 2. Now 0 is kind of in the middle between those two, so I'm just going to put 0 here right in the middle. And negative 4, so there's negative 1, negative 2, 3, here's negative 4. And over here we got positive 1, and here's positive 2. And let's see, for negative 4, this would be an open hole on negative 4. So I'll put an open hole here. On the positive 2, it's going to be a closed, because it's also equal to this number, so that one's closed. So make a solid closed hole or circle. And as far as this shading now, p is less than negative 4, which is going to go off to the left. Less than is for left. And then this one over here says p is greater than 2, so greater goes to the right. So right on that one. So they're shading opposite directions when you see the word or. All right, so go ahead and finish up. Well, it concludes the video, but you want to finish up number 3 and number 5 here. Make sure you solve it and graph it for both of those. All right, and that concludes our session 2 on our review. So we'll have one more session right now as we keep reviewing through Algebra 1.